All right, back to business. So here now we are gonna multiply. We are gonna multiply polynomials, and that includes monomials, binomials, trinomials, whatever they want to call it, right? And since we're using multiplication of polynomial, guess which rule we're really gonna be capitalizing on here? The addition rule. Yay! Addition rule. You guys know my spelling again already. All right. So I'm going to start first with because the book progresses. It started with monomial and then monomial times polynomial and then binomial times binomial and then blah, 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 blah. All right. But don't worry about that. Let me take this nice and slow because I realize I've been talking really fast. All right. Now, here's an example of a monomial times a monomial. One term times one term. Well, one factor, actually factor. No terms because we're not adding or subtracting. So here, it's saying to multiply 3x squared y times negative 4xy. All right. These are not terms because there's nothing separating these two. So please don't mistake this for subtraction. And even if you did, they are not like terms because we have x squared here and an x here. Yes, we have the like factors here, but nope, we're not. When we're simplifying terms, they have to have the same base and same power simultaneously. So obviously, because of these two parentheses and no plus or minus separating these two, they are factors. So this is the factor negative 3. So what I do just to break this down, I multiply factor by factor, or I should say I multiply like factors. So I pulled out my two constants, then I pull out my 2x factors to make them the same base because I want to use my addition rule, which says xn times xm is the same as saying x to the n plus m, right? So I'm pulling out my like bases. I can only add powers if the base is the same. Again, I repeat, I can only add powers if the base is the same. I cannot say xn times ym is equal to, I don't know, xyn. I'm making stuff up. The base has to be the same. All right. So I'm putting my like factors together. So you see, I put my x together, I put my y together, and remember that x is the same as saying x to the first power. So they don't put 1 because it's redundant. This is saying I have one factor of x, which is right here. I have one factor of x. But for the sake of not getting you confused, it's always safe to just put the 1 there just to help you out. See that? I put the 1 there so your addition concept could be executed clearly. Good. So now I have my like factors together, my constants, my x's, and my y's. Now I'm just going to multiply. So this is 3 times negative 4 is negative 12 because factors with opposite signs yields a negative. I have 2 factors of x here and 1 factor of x here. So I have 3 factors of x. Or if I'm multiplying same base, I add powers. 2 plus 1 is 3. I have a factor of y here and a factor of y here, which gives me 2 factors of y, or y1 plus 1 is y2. So my final answer is negative 12x cubed y squared. All right. So here we go. Here's a little caveat here. Here we have, this is not just the addition rule. We have the addition rule, right? Which is, I'll rewrite x to the n plus m, but we're also seeing a power outside here. Now be careful. The base for this x cubed, the base is just this. The base is just this factor negative 4x squared yz. It's not applied to the entire expression. If it was, there would have been a big bracket between here, and then that 3 would have had to be distributed to all factors inside that bracket. But the base here is only to negative 4x squared yz. So this I'll have to apply the multiplication rule. So like the order of Aunt Sally, even though we're dealing with strictly factors here, this here, we got to treat it. You see what happened? The addition rule is here and the multiplication rule is here. So we have to work on our multiplication before we can get into doing our addition and keeping in the order of operation. So my base here is saying that I have 3 factors of this entire factor here. But instead of me expanding it 3 times, I'm just going to use my multiplication rule. So I'm going to say 3 times negative, and it's to every factor in this parentheses, every factor, right? So I'm going to say negative 4 cubed, because that is negative 4 to the first power. 1 times 3 is 3. Then it's 2 times 3, and it's 1 times 3 and 1 times 3. You see that? For y and z, they are raised to the first power, so I'm timesing it. So basically, it's like you distribute power, which is the same as multiplying the powers. So notice I didn't touch this one as yet because I got to get rid of my product before I could get into adding the powers. So I rewrite my first factor where that exponent does not apply to. And then I do my distribution. Negative 4 cubed is negative 64. Remember, when you have a negative with odd powers or odd factors of a negative, it's still a negative. 2 times 3 is 6. 1 times 3 is 3, and 1 times 3 is 3 for y and z respectively. All right. Now I can do the same thing as I did with my first problem. Now I can group my common factors. Now, if you can see right away that negative 2 times negative 64 is positive 128, good for you. But just not to make mistakes and just be in the beginning process of this practice, I would say just group the common factors before you become a hero, okay? Heroes die, so don't go being a hero. Just take your time, take your pace, take your problems and dissect them, bisect them, and work them out. So here we go. I put my common factors together like bases. So I have negative, and negative is positive. That's 2 times 64 is positive 128. I have 2 factors of x and another 6 factors. So I have a total of 8, right? Same base, add powers. 2 times 6 is 8. 1 factor of y and 3 factor of y. So I have 4. 1 plus 3 is 4. And then I just have z3. There's no other factors to add to z. So I just have 3 factors of z. And my final answer is 128x to the 8y4z cubed. All right. Now, let's move on. So here we were working with monomials. Here we have monomials that raise to an extra power. And here now we're going to have a monomial times a polynomial. We need 1 factor times a group of terms that has 3. So these technically, once they're in parentheses, they became factors. So these technically are like 3 factors in some way or another. So we're going to distribute the factor to the group of terms, right? So here we go. Remember, whenever we have a factor times a group of terms, we use distribution. So here it is, negative 4x times the first term, positive 3x squared. That is negative 4 times, just for the sake of time and for the sake of you understanding how this works, we don't have to do 4 times 3 and then x. You could do it if you want, but it'll be a long sheet of paper. So this is negative 4 times positive 3 is negative 12. x1 and x2 is x3. This is negative 4 times positive 2 is negative 8. x1 and x1 is x2. And this is negative 4 times positive negative 1 is positive 4 and just x. Or we could say this was x to the 0. And 1 plus 0 is still 1. All right. So that's it for working with monomials times monomials and polynomials. Now let's get a little more action in. Here we have a binomial because it's 2 terms times a polynomial, or a trinomial is 3 terms, right? But these are just polynomials times polynomials. I'm just, showing off my mathematical vocabulary skills. But anyway, you get the point. So here we'll work term by term. So we'll treat each term outside as factors, right? So here we go. We're going to start with x times all the terms in the next parentheses. So I have x times... I have 1 factor of x and times 2 factors of x, it gives me 3. 1 factors of x times 1 factor of x, so it gives me 8x squared. Positive and negative is a negative, right? We have positive x times positive 9 is positive 9x. Now here is where your addition and subtraction polynomial comes in handy. Now, remember they were giving you a choice between a horizontal and vertical format. Well, I like the vertical format for when we're doing distribution of polynomials like this. So here I'm going to my next term, and here's what I do. I'm going to line up my like terms under each other. Because whenever you're multiplying polynomials, they actually become terms that you have to simplify. So when you're multiplying a group of terms times another group of terms, these factors become terms that you have to simplify, right? So we see how we got the first set of terms. Now here how we're going to get the second set of terms. So that's negative 4 times positive x squared is negative 4x squared. Negative 4 times negative 8x is positive 32x. And negative 4 times negative positive 9 is negative 36. So now I'm going to use the vertical format to combine my like terms. I don't have another term to match my x cubed, but I have two x squared terms and they're both negative, so I'll add and keep the sign. I have two x terms that are both positive, so I'll add and keep the sign. And I just have a constant term by itself. So this is my final answer. Now, here we have the famous binomial times binomial. And they use this method to call it FOIL, but it's the same method. It's the same method as distributing the first term times the group. I don't care how many terms. You could have 100 terms in here. 100 taking up this whole page going across. It doesn't matter. You will multiply the first term times the group of term here. Here has 3, and the only difference is that here has 2. And some mathematician come up with something fancy like FOIL, like it's something different, that something you gotta learn. You know how I get upset over these things. It's nothing different. You're doing distribution, right? All right, good. So my first term is 3x. I'm multiplying it by my first group of by my next group, my parentheses with my group of terms. So it's 3x times x is 3x squared. Positive 3x times positive 4 is positive 12. Again, I'm going to use my vertical format by putting like terms underneath each other so I can combine them. So I'm using my next term. It's negative 2 times positive x is negative 2x because they don't have produce an x squared term. And negative 2 times positive 4 is negative 8. And then I combine my like terms. I don't have any x squared to combine this with, but I do have two x terms with opposite signs. Subtract, keep the sign of the greater magnitude, and I only have my one constant term. And that's it for multiplying polynomials, guys. That's it. And this is slowly delving into our introduction of factoring, because factoring is actually it's actually the reverse. You see, what's happening here is that you have your terms in factored form. And when you multiply them, when you multiply your terms that is in factored terms form, they become terms. Again, when you're doing factoring is the reverse. You will have to take these terms and convert them into factors, and it's usually the binomial. It's usually in the binomial form. So here you have your term as factors and convert it to terms, and factoring is the reverse, taking terms and converting them into factors. All right, so this is why I call this your introduction to factoring. Our next video, we will be doing division of polynomials.